So most of you have not seen the countdown timer because I just realized that the go live was not actually live. But Tanner and I have been back here jamming out to the go live music. Tanner Linsley, it is great to have you today. How
Thanks.
you doing?
I'm doing great. Happy to be here.
And thanks to everybody for being here already. It is a happy new year to you all. This is the first show of the year. I am super excited for it. And yeah, without any further ado, I have one quick funny inside story about Tanner, which he may not actually remember.
Oh, no.
And that is that when I was in one of my first developer advocate roles, I had reached out to him on Twitter, trying to, compliment the libraries he was working on and trying to do some sort of like an outreach thing. Thoroughly calling him Taylor throughout the messaging. So, do your homework, people. Read people's names.
I probably rolled with it. I was just like, yeah, cool.
You did. You rolled with it, and in the end, you were like, "By the way, it's Tanner."
All right, good. I'm glad I wasn't a jerk or something.
You were
like, how dare you?
So that was pretty funny.
All right.
Yeah. So Tanner, why don't you let everybody know kind of who you are, what it is that you do, and we'll kind of kick it off.
Sure. Software developer. I build a lot of open source software publicly. And more privately, I am a co-founder of a company called Nozzle. And Nozzle is it's a search monitoring tool for SEO people. Simply put, we are, Google is scraping the web to create their search results. And we are reverse engineering that by scraping Google and trying to build, this huge database of Google search results. So you can imagine all of the data that you could get from that, why you rank where you do, rankings over time, estimated traffic and click-through rates. And, there's so many SEO terms that we could go into. It's this crazy world, but we are essentially just trying to reverse engineer why Google search rankings are the way they are. So
now Google has data. and so it would seem like there's probably been a couple of problem cases that have arisen between both the displaying of that data, the interacting with that data. So how much, and I'm guessing a fair amount, but how much of your open source work was scratching your own itch or solving problems you were coming across in the building of the Nozzle tooling?
A lot of it. I would say a majority of it, to be honest. If I go through we could probably step through the timeline of any of the libraries that I've made, and I could probably pinpoint we were working on that in Nozzle at that time. There's only one library that doesn't fit that pattern, and it was React. Well, no, even React Static when I was building React Static. But that was mostly just because I wanted to build a marketing site. We were using Hugo at the time, and I was like, I do not want a template in Hugo. I'm a React developer. Let me template in React. So I looked around at the competition, and at the time, it wasn't super competitive. Gatsby was around, but they were still pretty fresh. Next.js was around, but they were still working on static exports, I think. So, it was a fairly new landscape at the time. So I decided to build React Static, and it did pretty well. It competed on the bottom end of that spectrum fairly well. At the end of the day, though, that was not my MO, and I already have a startup. I mean, if you look at that landscape today, it's almost like you have to raise money and have this massive team if you plan on playing in that space.
Oh yeah, I mean, we've seen that with all these guys. Yeah.
Or have a big company like Vercel to be able to, justify maintaining it as this massive, infrastructure lead generator thing. So It was not a course that I wanted to go down. So I immediately was just like, hey, the top contributor to React Static, you can just take it. And they did, and they still work on it. But I'm glad I did that so I could move on to other things. But full circle, go back to what I was talking about. Like React Table was the first big library that I was like, I need tables in React. So I built that. Then I built React Query was the next one that really took off. React Charts is kind of a continuation from my early days of open source when I worked on Chart.js. React Location is another one. So yeah, all of these are mostly to solve very specific problems that I've experienced in Nozzle.
Well, and React Location is your newest, right?
Yes. Yeah.
And how would you describe that? I would, the brief kind of overview that I had on it, it seemed like it was sort of like a drop-in router replacement of sorts, or how would you describe location?
It's definitely a router. It would replace something like React Router or another client-side router. It's not specifically built to do SSR or anything having to do with server-side stuff. So if you need SSR or you want SSR, you should probably be using a framework for that anyway, like Next.js or Remix or something like that. But this is for like client-side rendered applications. I specifically built it to take advantage of the trade-offs that you would experience writing a client-side only app. And then it has a lot of added features on top of that I think are very important for what I'm doing at Nozzle. We do a lot of like URL sharing, and we have massive amounts of dashboards on, throughout the app. Every widget has state stored in the URL. So the URLs we're sharing are like these big URLs, but you pass that URL across to a friend, and React Location can take all that state, and it's serialized, and it's really cool. It's kind of just like you can just share your entire app state over with the URL.
Yeah, it's a snapshot. It's essentially it's a state snapshot. I remember I did a very naive version of snapshot sharing for a accessibility testing tool, and in the first React projects I had done was like, you could give it all these, because they're working in a branding agency, and all these colors inside of these widgets, and it would kind of show you if the text that you'd chosen was compliant. But the shared state for that made just like a paragraph URL that wouldn't even load in most browsers. It was like most browsers would just choke on too long of a URL. So yeah, location is rough.
With React Location, it's instead of like trying to do like a snapshot to the URL, I tried to make it so that it feels like you're using React state, like use state or something like that. And it's just storing the actual JSON in the URL. You can encode it a bunch of different ways. I actually use URL compression in Nozzle to synchronously compress the URL down, make it small, kind of cool. But yeah, that's the whole point. I wanted it to be just as easy to store state in the URL as it is to store it everywhere else these days. And when I was using React Router to do that, I was bumping into the ceiling of the React Router API as Nozzle's dashboards and everything started to grow and scale. So there were some growing pains there. And eventually it just justified, building my own. So.
Yeah, no, and that makes a lot of sense, because that is a very specific niche. I think that kind of qualifies a lot for the libraries you build, is you're building a lot of these, I was going to say tailor-made, but then I caught myself, but then I said it was okay. Tailor-made
I have some
libraries.
tailor-mades.
Yeah. These specific projects that are solving a very scoped use case that is in itself kind of a feature. You're not creating something that needs to be ripped apart for just the parts that you would need, or trying to replace an existing ecosystem that's already really robust. You've got these tools that, like, for example, when I had written the React Query integration with Hasura article, I talked about how focusing on React as opposed to this is the library that's going to work for Vue, Svelte, whatever, it does create a lean tool that's able to just lean into the primitives that specific framework offers. So it's like hooks all the way.
Right.
It's very, very React first methodologies. And that makes a lot of sense for solving cases like for a specific framework, as opposed to building a tool that's general purpose that can be really, really big. You're trying to navigate through the docs. The one framework releases an update, and then you're trying to update and fix things that are patching in one place but are breaking in another. And I think it's makes a lot of sense. So
yeah, and it's getting interesting the way you bring up like cross-platform, cross-framework type stuff, right? There's definitely a discussion to be had there, because React Query was the first library that I built that was people are like, we want to use this everywhere else. It's like, oh, really? And so there was a big rewrite that happened for version 2 to essentially make the core of React Query agnostic and just kind of vanilla TypeScript. And then there's this very thin wrapper around that core to make it work for React. It's still the dominant export and marketing path for React Query, but there is this core internally that really, if you wanted to wrap it with with a similar external API, you could do that for Vue or Svelte or whatever. And there's people that have already done that. There's Svelte Query and Vue Query that people have they're importing React Query into a Vue or Svelte library. And it probably feels funny. They're just using the core, but it's pretty cool. And I'm really liking that. I'm taking that approach too with React Table version 8, the next big version I'm writing. So it's still very React focused because I don't want to spread my efforts across all of the frameworks and kind of build an okay product across all the frameworks. I still want it to be a really fantastic React product, but the core of it's definitely going to be very very agnostic to all the frameworks.
That's actually really interesting, because I have to say, when I had the chance to work with React Query for the demos, it was like, this is just a really nice lightweight library. Like the idea, so from the Hasura side, having the idea of server state being the source of truth is a methodology that we very much get behind as well, because it is something to say, like, in a lot of these applications, we have the tools in place today where you can mimic state on the server very simply. But a lot of the tools, are trying to either do everything in the client and then have a background synchronization method. But if you use something like GraphQL, which is just great for writing, data to and from the server, then it's like, actually, I'd almost rather just stay in GraphQL land and just have something handle the plumbing for me that keeps the local state synchronized with what it is that my server's telling me that it is, and everything else. It was a really just like great pairing, and then that coupled with GraphQL CodeGen. Was that a community contribution, or did you actually write that tooling for
that? Was
CodeGen?
Community contribution, and I think they really nailed it. I've seen it used in a couple of places, and it looks fantastic. That and along with TRPC as well, which is I don't know if you've heard of TRPC.
I've heard of it, but go ahead and give a breakdown again on what it is.
TRPC, it uses React Query under the hood, but what it is it's creating in a full stack system, it's creating type safety between the back end and the front end calls. So while it's not bringing to the table everything that GraphQL would bring you, it is solving that piece of it. And I can't remember if they use a little bit of, I don't think they use CodeGen. I think they use like some live TypeScript stuff. It's pretty magical. But seeing the GraphQL code generator stuff come out of React Query and then this TRPC stuff, I'm like, wow, this is to me, that's a testament of a tool that is, like you said, lightweight enough and modular enough that it can just solve one thing and do it well, and kind of become a part of these bigger systems. And in fact, Blitz.js uses React Query. And I've seen a lot of other, larger scale engines use React Query under the hood, and it's not something I really expected to happen. But
When did you write it? How long ago was it that you actually wrote it?
No, I can't remember. I want to say at the end of 2018, I came out with the first version. Now I can't really remember. I wrote it internally at Nozzle as a replacement for all of my Redux. Like I was like, I'm using Redux everywhere, and I liked Redux. It was cool, but it got into this like, okay, there's this weird life cycle attached to server state that doesn't exist with the rest of my Redux state. It's like constantly updating, and when do I pull for new stuff, and the concept of like invalidations and whatnot. And I figured out that like a majority of all that Redux state was this server state, right? And this is back when like the term server state wasn't even really a thing, really. It's just kind of me and a bunch of other people at the time were kind of latching onto this term, and I thought it was great. But at the time I was like, wow, all this is server state. And so I did kind of a smoke test and I took all the server state out of my Redux and just like threw it away as if I was moving it to something else, and what was left was just tiny. So I was like, I need to build this. And that's kind of where I started building React Query. At first, it was an internal tool in Nozzle that used Redux as the store, but it just had a bunch of the lifecycle that was custom. Eventually, it only took a few weeks to actually move it out to React Query and publish it. So the first version was meh. I mean, it was great, but nothing compared to what it is today. The original API was inspired by a tool called Dracula. I don't know. Have you ever heard of Dracula?
Yeah, I mean, I'm in DevRel, so I've heard of almost every tool at least once, but you have to give me a refresher on that too.
Let's see, Dracula, GraphQL. So it was a GraphQL client made by Vadim Demedes, I think. And it was Dracula with a Q, but it was like a really lightweight version of Apollo almost. And if you go and look at the API for Dracula, you'll see some of the roots of like React Query's API in there. It's pretty cool. Oh, draculajs.com, Dracula with a Q. It was really cool, and I really liked some of I really liked the methodologies that it had as like a public API, but I knew that none of the internals would be able to work the way that I needed them to work for React Query. So I definitely took a lot of inspiration from the public API that they had, but anything that had to do with GraphQL and the internals, I just had to rip out and kind of make agnostic. And I chose promises just to be, I'm like, hey, we're just going to use promises instead of be like GraphQL or REST specific.
Yeah, no, and it's, I mean, it really is great for prototyping too, because you can also just say, well, here's the demo of what data I will be eventually expecting from the server, so I can go ahead and stuff this in there for an example, and works really great. I love how it's got the optimistic UI mechanisms in place as well, so you can do the rollbacks and you can be able to kind of get a snapshot of what the previous state was. So if the mutation didn't work, you can roll back. I mean, like, it's just like everywhere you would want to have a mechanism in place to do some sort of feature. It's you can tell somebody who was using it to solve a problem built it. It wasn't a theoretical exercise.
Yeah, the optimistic stuff came. So much of Nozzle is dashboards and charts and tables, and but there's a huge side of it that is this admin layer. It's a big SaaS product, and we're not talking about just configuring some settings here and there and team management and whatnot. Like, our users have to manage these huge pools of keywords and locations, and and all this criteria for how they want us to go and get our data. And some of our clients are managing hundreds of thousands of those keywords and permutations. So being able to, incrementally and optimistically do as much of that as possible became not just a nice to have, for performance and whatnot, but it became critical for our app to stay responsive. Like, I don't think a lot of applications other than designer software and or games or something like that are handling that much data. You think about your normal SaaS application that you're going to build in React, and it's kind of like, okay, teams, workspaces, permissions, some settings, users. But when you get into actual data, lots of it becomes really important. And those were pain points that I really felt when I was using Redux, and just when I was migrating to hooks too. Like being able to manipulate all that data. Forms are another one that we could talk about. Forms too. I had a form library. I don't know if anybody even remembers, but it's still there. It's called React Form.
Okay, I mean, it's a good name.
React-Form.
Somebody is an SEO person. You can tell, yeah.
I got into the form game for a while. I know, oh man, forms are so hard, and I decided eventually that I didn't want to be a part of that anymore, because forms are like it's so difficult. I ended up just going with a bunch of other tools and saying I'm going to put all my efforts into these other pots. I used React Final Form for a while. Eric Rasmussen built that one, and he did a good job. I used Formic for a little bit. Right now, I'm using a library from one of my open source friends that works at Tesla, and it's called Informed. Yep. And I think it just got inducted into the Tesla OSS. It's maintained by my friend Joe Puzo. And it's like a really healthy mixture of all of the great things that I like about Formic and Final Form and React Hook Form. So I really like it. That's what I'm using at Nozzle right now. And I feel confident telling people they should go use it as well.
Tesla Motors Formed. That's really cool.
It's one of those, like you said, with React Query, it's like, down the road, you're going to run into this use case where you're like, oh, I wish there was a mechanism for this weird thing I'm experiencing. And Informed has all of those mechanisms. Like everything is opt-in and it kind of shows up when you need it. They have, the 3 or 4 different approaches to forms, and you can mix and match them depending on your performance needs. And it's really cool.
Because it feels like you can look at the history of the different form libraries out there and see the history of the React framework itself. So whether it be render props or what was the one where you could like do the dot notation of child components. There's so many different generations of patterns that people were testing out. And it feels like each form library sort of sprung up with each one of these new ways of building with React.
Yep.
Died when everybody moved on to the next one, and then and kind of just stayed there.
And then hooks came out, and all the form libraries are like, oh crap. now we have to retool.
That's way better.
I know.
Yeah.
And that's when I tried to update mine with the hooks, and I was just like, that's when I kind of call it quits. It's like, no, this is not where I want to be. So
3-hit libraries is enough.
For sure.
To be. So I saw in one of these React 22 whatever survey things, what's happening this year, I came across my feed today, and you were a part of this panel of some kind where they were talking. I guess it just recently happened, where they were talking about the few things that are coming this year, and there was some information about the next version of React Query. So there's going to be some changes in the next version.
Yeah, there are going to be a few changes. Actually, I have a change log. I think. No, I'm not going to pull it up. We can just talk generally about it.
Yeah.
Aside from very minor the very minor changes that you're actually going to have to update, like mechanical ones where we're just kind of updating the API. There's going to be a lot of improvements to the way that React Query interprets network, like the network connection. Currently, if you're building an application that can work offline as well as online, React Query can kind of like get into that offline state where like it detects your network is down. And if you're trying to build an offline app, then React Query kind of is busted when you're in an offline state. Like your queries don't run because it thinks you're offline, and we primarily designed it to be, communicating with off
Server
computer server states, right? But technically, it's not just server state; it's just asynchronous state. And now that has started to include things like asynchronous React Native state, asynchronous IndexedDB, SQLite state, asynchronous APIs that are just come with the browser that are available, even when you're offline. So a lot of like the next version is going to have a lot more polish around being able to opt specific queries or the entire system in and out of this kind of, do my queries run in offline mode or not? And there's a little bit more state involved to offline mode and mixed mode, I guess you could say. Like the network's offline, but my queries can still run. It's a really interesting problem, and it's being tackled by Dominic Dorfmeister, or TK Dodo, as a lot of people may know him. Oh, whoops! I'm gonna send you his handle on Twitter so you can link to him. But he is fantastic, and I'm gonna be completely honest and transparent here. Dominic has been heading up most of the React Query progress and development for the last at least 6 or 7 months. He maybe more. But he's fantastic, and his passion for React Query is probably, even exceeding mine at the moment, just because I have so many other things going on. It really wouldn't be possible to like have React Query where it is today without him. So I'm sponsoring him.
I stole all of his information
Oh,
for the subscription integration. I'm like,
yeah.
I'm just going to grab this little bit because.
Yeah, I'm glad you posted his blog, because his blog is fantastic.
It's very good.
It's so good that we wanted to integrate it into the React Query docs. So there's a whole section it's not his section, but
it's like
all of his content.
Community articles or something like that, and it's like TK Dodo. No, they're very well done, and that's where I went to and referred to a lot of stuff for when I was trying to learn it and get my brain around it. So highly recommend. Yeah.
The other things that might be coming in V4, we're totally not sure yet. A lot of this has to do with timing, but we have been playing around with support for the next big version of React, right? Where everything goes, this concurrent features that you can have. So that has some pretty significant impacts on libraries that are doing data fetching and low level, like, global state management, I guess you could say. And React Query is a global state manager in a technical sense. It has a global store, for your entire app, maybe multiple, I don't know. And it needs to be able to pipe that information down through the component hierarchy. When you start getting into suspense and concurrent rendering, there's a whole bunch of funny things that start to happen when you expect your component tree to all communicate with this global thing, but some of parts of the tree could be rendered twice at the same time, invalidated. Some of them could be rendered and incomplete, while the other ones are rendered and actually painted. So it gets really funky. And TK Dodo, Dominic, has been on the working group for the React 18 suspense for data fetching, and he's been working very closely with them. And also we've anxiously been watching like Mark from Redux, Ace Mark, to see what they're doing as well. It's a complex problem, but we're we're pretty sure that either with the next release or very soon after it, when React 18 goes stable, that we're going to have pretty good support for the new concurrent features. So that's kind of another big thing that we've been working on. We're trying to do as much work as we can now.
Yeah,
So
it's always difficult,
out,
right?
You just kind of you flick the switch and it works. So
yeah.
Outside of that, there's a lot of other ideas that we've talked about for the next big version that we're not totally sure yet. One of them that we really wanted to do, and I don't think TypeScript is capable of doing this yet. So we've decided to pull back on it for now. But one of them was removing all the different overloads for the entire API and just sticking with one, a single object that you pass to all of the functions. So use query would just take an object. Simplifies a lot of things, and it simplifies the API and syntax that you see on the internet. So
that would be interesting, because on the one hand, and I'm the worst developer to reference because I learn weird. When I look at the API, it informs me as I'm actually I'm learning based off of all these different named conventions and all these overloads, like description. It's like, okay, I can kind of see how this is supposed to behave, but I can also see the benefit for streamlining the API.
When there's one way to do it, instead of seeing a bunch of overloads and wondering, well, which one should I use? There's kind of just one and it works for everything. And it unifies, it can unify the ecosystem and the docs as well. If we have to document all of those different ways of using it, then getting rid of 2 of the 3 overloads could bring down our doc size too. So it's more of a managerial update. And then, so we'll see if that actually happens in the next year. I don't know if it will. TypeScript is currently not able to infer some things correctly based on that style of usage. Some other things that probably won't affect most people. Well, no, they will affect people, but I don't know if they're going to come in V4, maybe soon after with the React 18 update. But we're hoping to move everything to a mono repo and individual packages, and possibly even a TanStack namespace. We've just talked about it. So all these things are teasers, but it's fun to talk about.
We got a couple of questions here in chat that I want to get to. So we've got a couple of people that are drawing some parallels between the recent updates to Appsync from AWS and some of their offline primitives for promising data synchronization in offline mode, and a few people kind of wondering in general how offline mode will work as a whole. If I were to guess or to infer, I'm thinking some people are thinking there's a built-in data store mechanism in terms of the backend. So how do you store the data? You're doing this inside of local storage, or where do you store the local state for synchronization inside of React Query?
So by default, React Query is just an in-memory store. If you're not doing anything special, it's just in memory. So every time you refresh the page, there's nothing in the React Query store. It's just, unless you hydrate from somewhere, it's just going to start out fresh. So that is a common misconception when people talk about offline and React Query. They think that it's by default storing stuff somewhere. It's not, but there are tools that we've built for React Query that can do that. So if you go to the docs and scroll down on the left-hand sidebar, there's some tools called persisters and persist query client. And the query client persister interface is one that we designed so that it could be used with a bunch of different things. And right now we have persisters that work for there's a web storage persister, so that will work for local storage or session storage, and so you can set that up so that your query cache or your query client gets persisted down to the local storage or session storage level. And there is an async storage persister that can basically do storage to wherever you want. We've seen people store things into SQLite, IndexedDB, that basically anywhere that you could put serialized data, we're seeing that. So people have extended that to work with React Native, among other things. There's also one called Broadcast Query Client, which is an interesting one. It uses the same interface, but instead of storing the query client to somewhere persisted, it's sharing it across your tabs. So as if you have multiple tabs open to the same app and you are on one and you make a query, then that query would get stored through the broadcast query client and then get hydrated on the other tabs that are listening on that same broadcast channel. So there are a lot of these lower level plugins and wrappers that we're starting to see become very important for that type of story. And the important thing to remember is that it's a primitive. React Query is it's a primitive, and it's meant to be wrapped. It's meant to be composed into these larger solutions. So I don't ever foresee React Query itself shipping with some offline syncing mechanisms. It's not like PouchDB or it doesn't have its own protocol for doing all that. But it is easy to add that stuff in. Just like you experienced with subscriptions, React Query doesn't have anything with subscriptions, but it's easy to add in because there's a billion ways to do subscriptions. So
and I think that's partly what makes the library so compelling, is just it just goes far enough within a plugin architecture, because there's other libraries out there, specifically in the GraphQL space. It feels like a lot of the libraries want a all or nothing approach to your project. It's like, well, we want to handle your local state, and we want to handle your data fetching and your server and they want to do the whole thing. It's like, I just kind of want to reach out to this endpoint. This is the promise of GraphQL. I want to reach out to this endpoint where I have my data and I describe that data and I bring it back and I plumb it through my application. And then end of that relationship. I don't want to have to worry about a whole bunch of other pieces in place, or ripping out from the demos and the examples. Okay, I believe I can throw away these 15 files, but there's so much boilerplate here. I have to spend, all day trying to go through this documentation to figure out what's actually needed. And so I think it's really, really nice when you can say, okay, here's a lean tool that just goes far enough for these sensible defaults. I think is the best way to describe it. I think you even describe it that way in the docs, is that there's a sensible defaults. Is that true? Is that how you describe it in the overview?
Right. Let's see. The very first guide is called Important Defaults. So we call them aggressive but sane defaults. Okay. And it's because they are. Some people start using React Query and they're like, whoa, this is fetching a lot, Yeah. And it's like, okay, well, would you rather us ship it so that it doesn't fetch enough for literally every person who installs it? No. So we call them aggressive but sane defaults that you can easily change, but they're built to, the entire purpose of React Query is to keep your server state synchronized and up to date. So there's a lot of things that just ship out of the box with React Query that, they're supposed to work for the majority use case. But I mean, even the majority use case, it just doesn't work for everybody. Even at Nozzle, I have React Query, but we're using sockets to stream database events to clients for specific to the users. So every user has their own WebSocket channel, and we stream database events to that user depending on who they are. We have turned off all of the background focus, the window focus refetching and all that stuff, because we don't need it. The database events get streamed to the client, and then we just invalidate manually and granular. So,
and that's how I did it with the subscriptions too. It was just okay, turn off everything, but I want that I want the plumbing to be there, and then I'm able to actually just pump it and fill it as soon as my my handshake's complete with that first batch of data.
It's a good example of how like the same mechanism, but very different for what we're doing and very different for what you're doing. And even like Firebase, there's people who have built React Query Firebase, and their setup is entirely different because the first fetch is from Firebase, and then everything after that is coming from, you know, the Firebase streaming updater thing. So yeah, that's the whole point. It's just built to be modular, and you can tear it all down if you have to. And like you said, is architecture ownership. You know, if you buy into a system that is going to needs to control everything about your application, then the second that you need to break out of that system and you can't, it's going to be very frustrating. And we built React Query to, you know, be there for you when you need it, but when you don't want to use it or you need to bypass something, you can just break out of it and, you know, continue to own your architecture all the way through your front end app.
Yeah, that's really a great way to work. While we're getting ready for the next questions here, I want to just reach over to the community chat here and see if anybody else has any questions here. One person had made the question about AWS Appsync, and I do think that I just wanted to hop onto that question on the tail end of what you had just said. And when you are, again, going all in on a single ecosystem's mechanisms, while, I mean, AWS has enough like meat on their bones that you can kind of go pretty far with that ecosystem. There is something to be said for having abstracted tools. Like, this is my data sync tool, not necessarily my storage tool. So if I want to use local storage, or I want to use SQLite or whatever as my local sync, I can do that. So I think there's some benefits to be said there. So it's not, in terms of how AWS Appsync has the ideas of sort of a local state ability, you can do all the things that Appsync currently would do in terms of the data synchronization using React Query. But obviously Appsync, and you can use Amplify with React Query too. I guess again, It's just async state. So you can go as far as you want with that.
Yeah.
And
really it comes down to, like, with React Queries being a more primitive tool, there's going to be more wiring to set up. You know, like you can't just drop it in and it's all just perfectly going to work. You bring in React Query, and then you have your Appsync set up, and then you need to bridge the gap between those two. It might not be a lot of code, but it's still code that you're going to have to write because it's like it's a custom integration for you in your application with your data. But that's the whole point, is that we make it as easy as possible to abstract and write your own stuff. And once you get to that point, it probably won't feel very different at all, but at least you own it.
Nice. Very nice. What other questions do we have for any part of the TanStack? Maybe you even want to share your screen, or I could also share my screen. We could kind of go through the TanStack landing page and have a look at.
Let's see. Share screen. There we go. Can you see that?
Let me put it up here. There we go. Yep.
All right, I was just on that important defaults page for React Query. But right now, this is a very boring landing page for TanStack. Hey, sign up for the newsletter. Maybe someday I'll have some products. I don't know. But here's all of my open source libraries currently that live on the TanStack. So there's React Query. We've been talking about that. There's React Table. We talked about that briefly. React Charts, which is a charting library, not too much mystery there. And React Location, we also talked about that one. React Virtual is probably the only one we haven't talked about yet. And React Virtual is virtualization. We're talking about rendering virtualization. Usually it's used for like rendering long lists or rows in a table, but I could show you some examples right here. So here is the, we'll just go to like the hardest one to implement. This is dynamically sized virtual scrolling. So what that means is that all of these boxes all the boxes in this grid and this system are, let's see, that's not dynamic. Dynamic. Do we want dynamic or variable? I can't remember. Maybe it's variable that we want. Basically, you'll have a list, and all of the items in that list could be randomly spaced. Some of them could be big and small. So when you're virtualizing, this is a big problem because you don't know how big a box is going to be until you render it. So you have to kind of build this incremental cache of how big all the items are while you're scrolling. So you'll notice in this box right here, I'm scrolling down and we're rendering, I don't even know how many rows we're rendering, 10,000 rows. Obviously, we can't render 10,000 of these rows at one time in the browser. All we're doing, though, is actually, let's just open DevTools here really quick, and I'll kind of show you what's happening with this example. So if you look at this row 30 right here, watch the elements as we scroll up. You'll notice that as we scroll up, new elements, new divs are coming in at the top. Or if we scroll down, they're coming in at the bottom. So we're only rendering the specific nodes that might be in view, and we have some overlap. So we're going up as far as 5 elements in and out, to the top and bottom of the viewport of the scroll. It could be even bigger. And then we're manually setting the height of the div that we're scrolling around. So to render 10,000 items, we have to have a div that's almost 800,000 pixels tall. But we're only rendering these items inside it, and we're manually setting their heights to be specific to where they need to be rendered. So even if you grab that scroll handle on the side and just crank it down, you can see that we quickly get into these high numbers right here. This one is manually positioned 700,000 pixels down. So that's how it works. There's a lot of intricate, weird things that we do in React Virtual to make this possible. And there's a lot of other libraries that do this as well. Brian,
what's the implementation code of that look like? Just curious. Can you boost up the zoom there?
I'll show you right here. This is kind of one of the unique features of React Virtual is there's other libraries that do this. There's one called React Virtualize and React Window. Brian Vaughn did both of those, I believe, and he does amazing work. But both of those are component driven, so you have to render a component for them to work. React Virtual is hook based, so it's headless, so that we don't actually render any markup or styles for you. All you do is call the use virtual hook and you give it a size. And this is the size of your items, not the scrollable size. So
that's a count.
Yeah, it's a count. We have 10,000 items. And then you have to pass it a parent reference. This is the parent ref that contains whatever the scrollable element you have is. And right here, it's a div. So we're putting that parent ref on that parent div. And then it requires an estimate size function. And estimate size basically says, we think that every single row is going to be 35 pixels high. And you could estimate the size individually per item. But right here, we're just saying every single item is at least going to start at 35 pixels tall. From there, we can just define how big we want our scrollable box to be. So this box will be 150 pixels tall, 300 wide. The overflow is set to auto so that we can scroll. And then inside of here, you don't have to do exactly this, but you do at least need a wrapping element inside of here that's going to take on this total size. So the row virtualizer item that you get back goes onto this wrapping div. And this total size right here is like that huge 700,000 pixels tall measurement. It's being calculated by use virtual internally. So you set the height on there. You can set your width, position, whatever. Do what, the important thing here is it's headless. So this could be a custom component that you have or something from a UI library if you want. And then the row virtualizer also has these virtual items. And each of these virtual items right here in this implementation is just a row. So we're rendering a div for each item. We have to make sure that we give it a key that corresponds to, that individual row. Right here, we're doing some, item, some even odd stuff with the class name and the index. And then we just have to apply this style. There's a couple of different ways to do this. Like you could use top and left if you wanted. So you could put this virtual row start as the top. Here we're doing it as a transform because it's a little more performant. So there's a bunch of different ways you can apply this model. You know what I mean? We're choosing to apply it this way. So the height of this item is right here and the transform is right here. And that's really all it takes to build a virtualizer. But the nice thing is that we're in full control of all the markup and the styles. So
would that work with like pagination? So if you knew, okay, total item count, I've got 20, or especially in the GraphQL land, so I've got 10,000 items, and I'm going to fetch my first 1,000 or first 100. Would that have a mechanism in place there to work with, to loading in more virtualized items as I go?
Absolutely. So there's you can build your own callbacks for when these things are going to render, either through refs that, you can stick on these divs, or I believe we actually have some callbacks on use virtual. Maybe, pretty sure we do. So like as you could render all of the items, but then just have them empty. And then when you scroll over them, when they come into view, you can actually call their queries or dependencies. Or you can do more of an infinite scroll approach like this one, where right here we are just querying an API and these rows are loaded async. When we get near the bottom, you'll see that scroll bar change. It kind of jumps up because we're asynchronously loading more items when we get close to the bottom. So, I mean, you can't just scroll directly to the bottom of the entire list. This is an infinite scroll situation. But the more that we scroll down, the more we're going to load. So you could do it that way as well. I've seen people combine so many of these things. So they'll use React Query to do the asynchronous fetching and pagination. So they'll use React Query to do the actual data windowing. So it's very different virtualizing these rows versus fetching windowed data. So React Query can handle the fetching. React Virtual can handle the displaying of those windows. And if you wanted to get really fancy, you could stick all that inside of a table with React Table. So kind of marry it all together. But yeah, you can pretty easily hook those together. I'm kind of sad that this isn't using React Query in here. We should probably... Oh, it is. Look at that. Use infinite query. Use infinite query is coming from React Query. So pretty cool.
There you go.
There you go.
That's great. Hey, we're 3 minutes from the end here. This was the least amount of live coding because there was 0 that I've had in any of these chats. I'll just pop that off screen. There you go. But like, this has been a great chat. Really, really enjoyed it. There's so many great tools. I mean, as a React developer, very much appreciate the work of library authors like you, giving your time and money to be able to actually produce these kind of tools that make us all a lot more productive. So very much appreciate it. Tanner, what's the best place for people to find you around the interwebs?
Probably just on Twitter, Tanner Linsley. In fact, that's my handle everywhere. And I was even having a discussion last night with my wife. I was playing the new Halo on Xbox, and she's like, wait, your gamer tag is just Tanner Linsley? And I'm like, yeah, well, why not? So if you want to play Halo with me or any other game, you can add me on Xbox too. So I just use it everywhere. It's pretty easy. Yeah, if you don't mind too, I wanted to kind of give a shout out to some of the sponsors too that I have. I don't think it would be fair to talk about React Query or the TanStack without kind of mentioning these people, but all of these people down to this, this person right here, I don't know where they live, but they contribute to the TanStack. I don't know what they're building, but they use it and they think it's great. And also to the big players who are helping us build even more stuff. GitHub's new issue tracker that you can use in beta is using React Table. And so everybody here, I just want to say thanks. And especially Dominic Dorfmeister, TK Dodo. He's just fantastic. A great maintainer. You should go and sponsor him. I do. Also, I wanted to mention that this course right here is going to be outdated probably in the next month. We're releasing a new course that is going to be super, super awesome. We're launching it in partnership with UI.dev. Tyler McGinnis is a good friend of mine, and Alex Anderson is the one who's been working on it, and I'm just really excited about this course. It's going to be the definitive way to learn how to do basically everything you could imagine with React Query. So yeah, pay attention to UI.dev and our Twitter accounts to get that announcement, but it's going to be really fun.
Fantastic. Looking forward to it. Again, it's a great library. They're all really good libraries, but specifically React Query. If you are wanting to find more information specifically from the Hasura side, just have a search, or I'll just pop it here quick as well. The getting started with React Query and Hasura. But yeah, fantastic libraries, great tooling. Thank you so much for joining us. When you do release 4.0, then we'll have to have you back on so we can look at the updates and update the Hasura article.
I think next time we should probably bring Dominic on too.
That would be awesome. That'd be great.
So many good things to tell us and say about it. So
for sure, we'll make that happen then as a plan. So all right. Thanks, Tanner. Have a good one, and thank everybody. We'll see you all next week on Tuesday, and have a good one.